Hello my dear children. So in the earlier part, we have discussed about the frequency of sound. So under the frequency, we discussed that frequency is the number of oscillations or the number of vibrations that occur within 1 second of a time period. So now in this part, we are discussing the further things which relate to a frequency of a vibration. So you are given with an activity to investigate about the frequency of vibrations. So when you are doing this activity, you will be needing these instruments. So you know what are these instruments. In the earlier part, we have discussed and I have introduced to you what are these things. So these things are named as tune-in forks. These things are named as tune-in forks. Tune-in forks. So in our laboratory, there are several types of tune-in forks. In our laboratory, when you go to laboratory, you have boxes of tune-in forks. They have different sizes. They are in different sizes and different lengths. Their arms are the ones which are going to vibrate. According to the length of the arm, the vibrational pattern changes. So that's the whole thing in this activity that we are about to discuss as well. Right. So we need two tune-in forks that has a lengthier arm and a shorter arm. So I'll name this thing as long tune-in fork. Okay, tune-in fork with a long arm. Tune-in fork with long arm. Arm is the part which vibrates in here. This is called as the arm. This part which is going to vibrate, it is the one which is called as the arm. Okay, you need a lengthier arm and a shorter one like this with a shorter arm. Okay, so tune-in fork, this is the first material you need. Tune-in fork with a long arm, and the second material you need is tune-in fork with a shorter arm. Tune-in fork with a short arm. Okay, so these are the two materials you need in this experiment or in this activity, right? So we'll move on to the next thing to see the method. So the method is really simple in here. You take the long arm. So I'll draw and show you the long arm. You take this long arm. Okay. Then you have to vibrate this long arm, the tune-in fork with the long arm, you have to vibrate it. And you have to listen to the sound very carefully. You have to listen to the sound very carefully in order to observe the type of sound which is getting emitted by the tune-in fork that has the longer arm. Okay, we are going to compare the two sounds which are emitted by the two tune-in forks. So the first and foremost thing is vibrate the longer one or the longer tune-in fork, or the tune-in fork that has the longer arm. You have to vibrate it and listen to the sound very carefully when it is vibrating. Okay, so method: vibrate the tuning fork with long arm vibrate the tuning fork with long arm and listen to the sound carefully. And listen to the sound carefully. Okay, so you can observe the longer arm tuning fork. Most of the times when you take the tuning forks, I told you that there are several tuning forks. In the earlier slides we observed the tuning forks with several lengths. So most of the times, like in here, within their base, right, like in this kind of a place, most of the times their frequency is being printed. Okay, their frequency is being printed, right? Most of the times their frequency is being printed on the base of the tuning fork. Okay, so you can select a tuning fork with a high frequency, and you can select a tuning fork with a lower frequency. Okay, that's the whole idea of doing this experiment. We are going to compare the two sounds which emitted by those tuning forks that has two different frequencies. Okay, so when you are selecting two tuning forks, you have to select tuning forks with two different frequencies. In simple, tuning fork with a lengthier arm and a tuning fork with a shorter arm. Okay, right. So our next step is, we'll move on to our next step. Then you have to take the second tuning fork that has the shorter arm, like this. You have to take the tuning fork with the shorter arm. Then you have to vibrate it and listen to the sound carefully, as we done in the previous one. Okay, right. So vibrate the tuning fork with shorter arm vibrate the tuning fork with shorter arm and listen to the sound carefully. Okay, right? But remember, when you are doing this, first you vibrate the longer one or the shorter one, then listen to the sound carefully. Then after that you take the other one and vibrate and listen to the sound carefully. Okay, remember to listen the sound very carefully, because that's the whole idea of the experiment, to identify the differences between the two sounds. Okay, then the next one, we need to identify the differences Identify the differences of the two sounds. Right. So this is our method. You have to vibrate the two tuning forks carefully. Then after that you have to listen to the sounds which emitted by those two tuning forks. Okay. Then we have to identify the differences. Okay. Right, my dear children. So this is the way of conducting the activity. Right. So we'll head on to the lab and check how to take the observations from this activity. So we'll head on to the lab and we'll check how to get the observations from this activity like this way. Right, my dear children. Now we are going to study about the frequency of a sound. Okay, frequency of a sound. So I told you that to study about the frequency of a sound, we need to take two tuning forks. Now, when you go to your laboratory, the tuning forks are like this. Tuning forks are like this. So they not just one or two, but we can find several tuning forks with several arm lengths. So here you can see it, right? We can find several tuning forks with several arm lengths. So I'm going to take out 2 or 3 like this. So these are the ones which are referred as the tuning forks. So there is a hammer in the set, small bit of a hammer. We need to tap on this arm like this. So it's getting vibrated. So when you observe the neck of the tuning fork, here you can observe the frequency, the vibrating frequency of the tuning forks. So each and every tuning forks, they have a certain type of a number printed on it. So here 288, and here you can observe 256, 256, see, and in here you can observe 512, 512, and like that way there are several tuning forks with several arm lengths that has several frequencies, right? So now I'm going to take two of them like this. I'm going to keep away the rest, and I'm going to take two of the tuning forks. So I'll remove the rest. So these are my two tuning forks. Here you can see that this one has a shorter arm length and this one has a longer arm length. So here it's printed 256. Can you see? It's printed 256, the longer one, and the shorter one, in here the shorter one, it says 512. So let's see. Now I'm going to vibrate one of these two. So I'll take the longer one first. Right, my dear children. Now I'm going to vibrate this tuning fork that has a longer arm. Here you can observe it's printed 256. Here you can observe the 256, the number 256 in here, right? Just concentrate about the number, then I'll explain. When I'm going to go back, I'm going to explain what does this number means. So here 256, you can observe 256, and here it's 512. Now I'm going to vibrate this tuning fork that has a longer arm, and I'm going to give you to observe, I'm going to give a chance to observe the sound, right? So I have a separate microphone in here so that you can hear the sound clearly. So I'll vibrate this thing and we'll hear to the sound. So listen, you have to listen to the sound carefully when I'm going to vibrate this thing. Okay, listen to the sound carefully when I'm vibrating this tuning fork. Once again, so you have to listen, and now when I'm going to vibrate the other one, you have to find out the differences between the two vibrations. Okay, okay, now once again. Okay, now we'll use the shorter one. So I'll keep it away. Then I'm going to take the shorter one. The shorter one. Here it's been printed 512. You can observe it. Now I'm going to vibrate the shorter one. Listen to the two sounds very carefully and identify their differences. So again, the longer one. The shorter one. Right. So I hope that you have listened to the sound carefully. So when you take these two tuning forks, I told you that there is a number. So this number is the frequency, the number of turns or the oscillations which these tuning forks are going to complete within 1 second of a time period. Within 1 second of a time period, how many oscillations does these tuning forks are going to occur is being printed on the base of it. So when I'm going to vibrate this longer one, it's going to vibrate 256 times. It's going to vibrate or oscillate, means that the arm of the tuning fork will move to there and there, and once again will come back to the original position. This is how a one oscillation works. This is how a one oscillation is going to work. So when you take one oscillation, right, when you take one oscillation, it's like a cycle. It's moving there and moving over there, then once again coming back to the original position. So this 256 means, it's going to complete this 256. Here you in the base you can observe the 256 number. Now this 256 means within 1 second of a time period, this tuning fork is going to move, or it's going to complete 256 cycles. 256 cycles within 1 second of a time period. Within just a 1 second of a time period. Right? So this is the tuning fork that has the longer arm. Now I am going to take the shorter one, this thing. So when I am going to vibrate this thing, I could hear, when I am vibrating this thing, I could hear a sharp and an intense sound. It's because that here you can observe the number. It's been printed here 512. It's printed 512 in here. So you can see that the number of oscillations completed by this tuning fork, this tuning fork, when you take this tuning fork, the number of oscillations completed by this tuning fork within 1 second of a time period is 512. So this one is going to emit more intense sound, a good intense sound rather than the other one, right? So here you could observe that when you take these two tuning forks, the one which has the longer arm, this one, is not going to emit that much of an intense sound. It's somewhat intense, but not that much as the shorter one, right? So you could hear the intensity of the two sounds very clearly. It's because that their frequencies are different to each other. And also, when change in the intensity, when change in the frequencies, the sound emitted by these instruments are also going to differ. Differ means here the intensity is getting changed. So we could hear that, or we could observe that when you take these kind of tuning forks, they emit different types of sound due to change in the frequency of the vibrations or the frequency of the oscillations. So our observation, now we come into our observation. Our observation was very simple. When you are vibrating the tuning fork that has a shorter arm, when you are vibrating a tuning fork or the tuning fork that has the shorter arm, you can hear more intense sound. Very intense sound could be heard when vibrating the tuning fork that has the shorter arm. Okay? And when you are vibrating the longer tuning fork or else the tuning fork that has a longer arm, then you can hear a sound which was not intense as much as the shorter tuning fork. Okay? The sound which was produced by the longer one is not that much intense, but the shorter one produces a more intense sound. Okay? So that was our observation. So we'll write down our observation then. So this is my shorter one first, shorter tuning fork. So shorter tuning fork produce more intense sound. Shorter tuning fork produce more intense sound. Intensity of the sound generated from the shorter tuning fork is very high. We could hear it. There was a heavy sound given out by the shorter tuning fork. Then we come into the longer one. I'll use a different color. Longer one. Tuning fork with a longer arm. Okay. So the tuning fork with a longer arm is not going to give an intense sound. Right. So longer tuning fork do not emit so in here I'll name the tuning fork as I'll name tuning fork like this so that you could get more understanding. So I'll name the tuning fork like tuning fork with longer arms. Okay. Rather than the longer tuning fork, I'll use that term. Okay, right. So tuning fork with long arm produce less intense sound. Less intense sounds. Right. So this was our observation. What was that? The shorter tuning fork, or the tuning fork that has shorter arms, produce more intense sound. The tuning fork with long arms produce less intense sound. So that was our observation, right? So what is the reason, or what is the conclusion of this activity? Why does it changes the intensity? Why does the intensity of the sound is getting changed when the length of the tuning forks is going to change? It's because that during a vibration, the frequency is the factor which is getting changed when changing the length. So we can finally conclude that if it is going to produce more intense sound, then the frequency or the number of vibrations that occur within unit time is very high. So the tuning fork with a shorter arm, it definitely should have a higher frequency. If you take now after doing this experiment, if you see the base of the tuning fork, then you can observe that this shorter one has a high number and this longer one has a lower number. That number is the frequency. Of the tuning fork given in here. Okay, so you can compare those two. By the comparison, you can observe that the longer tuning fork has a less number of frequency, and the shorter one has a high number of frequency. So that is our final conclusion then. So we'll write the conclusion. So our conclusion was, use another color to write the conclusion then. So what was our conclusion? Longer, or else I'll use the term given in here, tuning fork with long arms. So tuning fork with long arms has high frequency. Therefore, it's going to emit. Sorry, it should be tuning fork with long arms has less frequency. Tuning fork with long arms has less frequency. So the intensity of the sound generated by the long arm tuning forks is very less. Okay. So here once again you can write intensity of the sound is less. Intensity of the sound is less that has longer arms for the tuning forks. So as a conclusion, we can write like this: intensity of the sound is less when it has a less frequency. Okay, when it has a less frequency, the intensity of the sound is very less. So intensity of the sound is less when frequency is less. When frequency is less. Right. So tuning fork with the long arms has less frequency. Therefore, it is going to emit less intense sound. So when reducing the frequency, we can finally conclude that intensity of the sound is also less. Right. Then we come on to we'll move on to the next one, the shorter one. Okay. So we'll move on to the shorter one then. Conclusion. Under the conclusion, we'll move on to write down the what happens in shorter one. Okay. Now in the shorter one, what happens? Shorter one produces more intense sound. Shorter one produces more intense sound. So shorter tuning fork produce more intense sound, therefore it has high frequency. So shorter tuning fork not produce, it has high frequency. Shorter tuning fork has high frequency. So therefore, what happens in shorter tuning fork is they have more intense sound. Intensity of the sound is high intensity of the sound is high when frequency is high. So this is the final conclusion of our activity. Once again, if the length of the tuning fork is high, then it vibrates slowly. Means that the intensity of the sound is also going to be less. It's because that they have less frequency. They have a less frequency. If you take shorter ones vibrate very quickly. So tuning forks that has shorter arms vibrates very quickly. Therefore, it has high frequency. So when increasing the frequency, what happens? The sound has more intensity. So this is the final conclusion that we can come with the given activity. Okay, so always remember, if the length of the arms are less, if the length is less, it gives more vibrations, means it produces more intense sound due to increase in the frequency. If the length of the arms are high, if they have higher length, then what happens? The number of oscillations or the vibrations which the longer arms are going to produce is less. If the number of vibrations are less, then the frequency also drops down. So when lowering the frequency, intensity of the sound is also going to be less. Okay, so that's the final conclusion from the activity. Right, then we'll move on to the next one. So here you can observe a set of tune-in forks, and I told you that the value of frequency is printed on the base of the tune-in fork. So here you can see that here 128, here 256, here 512, here 1024, then finally 2048. So you can see that the frequency increases when you are moving from left to right. Frequency increases, right? So we'll see the points which given in here. So it is clear to you that sound is generated by a tune-in fork differs according to the arm length. According to the length of the arm, right? According to length of the arm, the sound emitted by a tune-in fork is going to differ. It is the frequency of the sound which change in here, right? The reason for change in the sound is the frequency. In the earlier activity, we did that thing. We could hear more intense sound when the length is less, and we could hear less intense sound when the length is more. More with less, less with more. Remember. Okay. So the frequency differ according to the length of the arm. So here I can write like this. So in this figure you can observe, when moving here to here, when moving left to right, you can observe the length reduces gradually. So here to here, here to here, the length reduces. Now, length reduce. So when reducing the length, here you can observe that their frequency is also increasing. When length is going to reduce, frequency is going to increase. So frequency increases. So this is how the tune-in forks are going to emit sound during a vibration. So by comparing their frequencies, you can say that they are emitting different types of sound. When you take the musical notes, so I told you that musical instruments are also going to vibrate a certain part to generate sound. If you take a guitar, guitar is going to vibrate their strings to produce sound. So during the vibration, the frequency is the factor which is getting changed to create different forms or different sounds of the guitar. We know that there are 7 musical notes in an instrument. Those things are C, D, E, F, G, A, B and C. Usually we refer these things as Do, Le, Mi, Fa, Sol, La and Ti, right? So C, D, E, F, G, A, B and C. So these are the 7 musical notes. So when playing these 7 musical notes, you can hear different sounds. It's because that 7 musical notes are also created by changing their frequency. Okay. So if you move on to the next slide, you can finally conclude that these 2 given points. What are those? Number 1. Frequency increases gradually when decreasing the length. Frequency increases gradually when decreasing the length. If you decrease or reduce the length, it vibrates more fast. When vibrating more faster, it will generate more intense sound due to increasing the frequency. Then number 2, frequency decreases when increasing the length. When increasing the length, frequency decreases. When increasing the length, frequency decreases. Means that tune-in forks that has shorter arms have very high frequency, means that they are generating more intense sound as they have more number of vibrations within their arms. So this is the final conclusion we can come up with the activity. Right. So we'll move on to the next one. So here it is given that you can see the musical instruments. So if you take a musical instrument, as I told earlier, musical instruments are going to generate sound. If you take an organ is like this way, no? So there are keys like this. Like this, there are keys, right? So now I'll name the musical notes in here. So I'll use a different color one in, right? So what are the musical notes? C, D, E, F, G, A, B and C. So you know that our organ has several keys, not the 7, right? It has several keys. So once again it comes to C and it's going to repeat. Okay. So these are the 7 notes in the organ which you are going to play in different kinds of occasions. So when moving here to here, I mean from left to right, their frequency is going to change. That's why they have different forms of sound. So in any kind of a musical instrument is going to change the frequency. So by that way, they are changing the sound which is going to emit. So what happens now? You know that in an organ there are several keys, no? So I'll draw this thing somewhat further like this. So it has several keys. So once again the same thing is going to repeat. Same notes is going to repeat. See, then once again D, E, F, G, A and B, and once again this thing is going to repeat. So what's the difference between These 7 notes and these 7 notes, what is the difference between? Difference is, my children, is their frequency. Okay, so we categorize these musical notes as minor C, major C and middle C. It's because that they have variants of frequencies. Usually we play a song by using middle C. Okay, then there are two other notes called as minor and major. So when you are moving from left to right, the frequency changes, so as the sound intensity of the sound is also going to change. So that's why it has several keys to produce sound with several frequencies. If you play the C in here and if you play the C in here, even though they have the same note, their sounds are different because their frequency is changed. Okay, that's how the organ is going to generate different forms of sound by changing the frequency. Right. So my dear children, we have learned about the frequency of the sound and how does the frequency is going to change. So we discussed that frequency is going to change when increasing or decreasing the arm length or the length of the vibrational part, and we studied about the musical notes and how does the frequency is going to affect for the musical notes. And on the next part, we'll discuss further things related with the lesson.